Booz Allen is delivering mission-ready solutions, AI-powered, software-defined, and commercial-first. Combining deep mission experience with commercial partnerships, Booz Allen is defining a new defense industrial base, a network that crosses traditional boundaries to scale non-traditional technologies and brings our best tech to the hands of the warfighter faster, effectively delivering technology for today and tomorrow. Booz Allen, accelerating outcomes for today's warfighters.
Hello and welcome to the Emerging Tech Horizons podcast. I'm Liz Specht, a research fellow at NDIA's Emerging Technologies Institute. Today, we're going to discuss the importance of maintaining global technological competitiveness in biotechnology and the national security case for building a robust defense bioindustrial base. To dive into this topic, I am honored to be joined by Dr. Michelle Rozo, the Vice Chair of the National Security Commission on Emerging Biotechnology and Vice President of Technical Capabilities at In-Q-Tel. She's spent a decade in government with roles in Congress, the Department of State, Department of Defense, and the National Security Council, and is a molecular biologist by training. Thank you so much for speaking with me, Michelle.
Thank you so much for having me.
Could you start by providing a bit more of your narrative about your journey and how that kind of positioned you for your role as Vice Chair for this commission?
Of course, happy to do so. And you provided a wonderful overview already, but as you said, I'm a molecular biologist by training. I studied the molecular mechanisms underlying infectious disease, both chronic disease and aging in my PhD, and then I looked at infectious disease in my postdoc. But I knew across all of that time that I was really excited about the national security landscape, about policy, and that I wanted to get into government in some way. And so after my time at the bench, I did a AAAS fellowship. This is a program that's designed to bring scientists into government for a short-term period. I served on the Hill as a AAAS congressional fellow in the office of Senator Bob Casey. And in that year, I was able to work on the authorizing statute for the Department of Health and Human Services, what gives HHS the authority to prepare for and respond to infectious diseases. And so that was a really exciting foray into legislation and how that works. From then I went into the executive branch, and you listed out a number of the places at which I've served. Department of Defense is really where I first understood that biology was much more than human health, and happy to get into that in much more detail over the course of our time together. But it started my love affair, if you will, with industrial biology and biomanufacturing, which I know we share in common. And then I left government and joined In-Q-Tel and then began my service on the commission. So with that intersection of biotech expertise, as well as an understanding of the national security context across a number of different agencies in the U.S. government, I brought that vantage point to my role as vice chair. But I should say across all of our commissioners, we have a breadth of expertise spanning world-renowned academics, world-renowned industry members, former very high-ranking officials across the Department of Defense, the intelligence community, Congress, as well as sitting elected members of Congress. And so we had a really diverse set of background and expertise with which to bring to the problem of biotech and national security over the last few years as a commission.
Great. Quite a blending of backgrounds there. Could you tell us more about kind of the impetus for forming the commission? Who decided that this was the moment that we needed a commission to look into emerging biotech?
Yeah. So let me start with just saying what a commission is and how people can think about it. I think that's a helpful framing. So you can think of commissions like a legislative advisory board. In the case of biotech and in other tech areas like AI and cyber, legislative commissions were created because the topic was too complex for one member office or even one committee to tackle on its own. Biotech, and you'll see when we talk about our recommendations, touch basically every committee on Congress, across Congress. And so that's really too much for one individual office or one committee to tackle. So recognizing this and recognizing that biotech would have an outsized role to play in national security in years to come, Congress passed the authorization for our commission in the 2022 National Defense Authorization Act, or NDAA. And that really was the language that stood us up. They had great foresight, I would say, because biotech is even more important now for national security than it was at that point. And what that enabled us to do over the last 2 years across the breadth of expertise, as I described, and importantly, our bipartisan and bicameral members of Congress, was to really look at biotech and national security, which we defined very broadly. to mean everything from health security to food security to economic security, and of course, defense and traditional military and national security issues, and really understand the state of play here in the United States vis-a-vis adversaries like China. And I'll say Congress had some foresight in thinking about this, because we are arriving at what we like to say is this chat GPT moment for biology. This is both a really intense technical leap forward in biotechnology, but also the public understanding of the technology, and really that intersection together, are really arriving at what people are saying is like the age of biology. And what that means is it's this advance in life sciences and engineering and automation, artificial intelligence. I like to say that we're able to program cells now like we can program computers. But that's even kind of limiting, because when you program computers, it's like the only output you get is ones and zeros. You're still limited to what's in a computer. When you program biology, the limits kind of don't exist. You're limited by what's in life around us. And you just have to look at all of the things that biology has created itself to do to see why that is really a wide breadth of potential. You could think of things like taking entire diseases off the table, solving for food security, remaking our entire global supply chains. Really, all of that is possible and within reach to make every individual life better here in America if we grab the leading edge and hang on to it and arrive at this chat GPT moment first. But unfortunately, what we found over 2 years of work is that we are in danger of losing that leading edge to China. They have made this a strategic focus for the last 20 years, and it's paying dividends. And we have so far failed to do the same. So what we came out with in April was our final report to Congress, which laid out this state of play over, as we did this analysis over the last 2 years, and the suite of legislative recommendations, so that Congress could pick that up and act on it. And really, in doing all of that, we've served our function as this legislative advisory board.
Yeah. I want to follow up on that. You mentioned this is your final report. You also had an interim report.
That's right.
How did you see the landscape changing, even just in the year-ish between those two?
I mean, it's even changed since we released the report in April, and we were pens down at the end of December. I mean, the rate of technological progress, as well as China's progress, is just almost exponential. So in our interim report, we came out and said the US had the lead, but we were in danger of losing it. And even in the year between the interim report and the final report, we said, you know what, China is actually superseding us in certain areas. And since we released the report, we see that not only to be true, but that is being demonstrated at, I would say, an even more increasing rate than we had even anticipated. And you just have to look at the continued announcements of large multinational pharmaceutical companies making these big investments into Chinese biotech for innovative IP and licensing deals, as opposed to US or Western companies. And that's just really signifying that in these specific sectors of oncology, China is not just fast following us anymore, they're out innovating us. This could be first in class, best in class drugs. This is a whole new paradigm.
Yeah. I'd love to turn to kind of defense applications, and in particular, the biomanufacturing component of this, the defense bioindustrial base. Could you talk about what you see as kind of the major advantages of building a robust defense bioindustrial base, how that complements with sort of a traditional defense industrial base?
Of course.
Or what new capabilities that gives us?
Yeah, so I like to break this down into two ways, two things that biology can do for the DoD. The first is provide new means of producing things the department needs. And let me go into this in a little bit of detail. So the Defense Department obviously buys a lot of things, right? They are a massive consumer of products and rely on this massive industrial base, I should say, defense industrial base, in order to serve products into the DoD. But a number of the components of those products are sole sourced or foreign sourced, which leads to potential vulnerabilities in those supply chains. This is a problem, that exists for some time, and one that we're continually trying to address and provide more resilient means of supply chains for the Department of Defense and for the government writ large. Biology can change that. And so I say those things, but I think it helps to actually walk through some examples so that people who are not biologists can actually understand this with a bit more granularity. And I say this even as a biologist who didn't fully understand this until I came to the DoD myself, because I was only doing health-related biology, which is, I think, what a lot of people see when they see biotech. They think medicine's in their cabinet and not other things. So The example I like to give is of brewing beer, because it's one I think everyone conceptually understands how that works. So we have yeast, we give yeast sugar, and via their natural metabolic pathways, they convert that sugar into alcohol. Well, now with emerging biotechnology techniques, we can engineer yeast so that they can take in sugar or other types, that can come from corn, that can come from other types of starting materials as well, and transform that into other products, things that can be drop-in replacements for things the Defense Department uses. And so an example of a bio-based manufacturing process replacing a foreign source or sole source product is one chemical called BDO that probably no one has ever heard of, but it's something we use on a daily basis. So BDO is a chemical that's traditionally made through petroleum, and it makes spandex, it makes polymers. It might be in our clothing or in these chairs that we're sitting on. It's probably in your car. Just this one chemical alone is a $5 billion a year annual industry. And BCG has written extensively about this. Of the 5 major manufacturers of BDO, 4 are in Asia, 1's in Taiwan, 3's in China, and 2 of those in China are in Xinjiang, which has some implications potentially for the labor that supports that facility. Now, pivot to bio-based manufacturing. There are now companies that are innovating around making bio-based routes of production for BDO. This is functionally equivalent to the chemically produced BDO, but it's made using that manufacturing process that I described earlier, something akin to yeast transforming sugar into a BDO instead. And now there's a facility that's being built in Iowa that's taking corn as the starting material and that feedstock, if you will, into this manufacturing process, of which the output will be bio-based BDO. Again, functionally equivalent, but a domestic route of production. This is a safe manufacturing process. It's a good job. It's taking corn that's made and grown in Iowa and making it a value-added product on the output. So this is a potential additional source of revenue for farmers as well. It's kind of a win-win-win, if you will. And we're just really scratching the surface of what we can remake manufacturing-wise with biology. So this is one thing that bio can do for the DoD, is remake global supply chains using biomanufacturing to have the exact same product come out the other end, but have it be here in America, as opposed to a vulnerable or foreign source. If we extend this metaphor a little bit more, the other thing it could do is make that product where it's needed. So we know that you can brew beer in a brewery, a full-scale brewery down your street, but you can also have a home brew and make it in your house. Same goes for biomanufacturing. So you could forward deploy the manufacturing process as well. So not only make it here in the United States, but make it in the field where a soldier needs it, be able to solve for some of those resupply and supply challenges. Okay, so that's all one, right? Just making the things that we already make, but doing it with biomanufacturing and doing it in a way that's more flexible and nimble. The other thing that biology can do is make entirely new products via biomanufacturing with new capabilities and entirely new functionality. And if I said we were just scratching the surface of this first bucket, we were really not even scratching the surface of the second.
Right.
I mean, we are just beginning to understand the breadth of all of the things that biology can do and the number of ways that it can solve for military problems. So one example of which is materials with resistance to high temperatures. This is just a little fact sheet from OUSD R&E and a specific program at the DoD called TBRISC, or the Tri-Service for Biotechnology for Resilient Supply Chain. They're using biomanufacturing to make next generation materials that are resistant to high temperatures that could take the form of next generation mortar tubes or high-speed platforms or new batteries. So really cool capabilities. And again, really just scratching the surface here. One other example of a new capability that I like to share, this one on the medical side, is that of synthetic blood. So there's a critical period of time after injury where access to blood saves lives. This is called the golden hour. If you can get blood within an hour, it improves chances of survival. But blood is hard to come by when you're deployed in the field or in remote parts of the United States where there's not close to hospitals that have access to blood banks. So what the DoD and DARPA is working on is synthetic blood. This is shelf-stable blood. You kind of crack this bag like a glow stick, and it turns the golden hour into a golden day. So really cool capabilities. Again, really just beginning to explore all of what biology can do. But the bottom line is that it can solve military problems across a range of issue areas, of which, again, I think we're really just beginning to understand the breadth of.
Yeah. I mean, your point before of like, there's just so much creativity out there in nature, but now combining that with AI-inspired protein design to produce things that have never even, evolved naturally. Like you said, barely scratching the surface.
Exactly.
I want to kind of pull a thread also on this feedstocks component and how powerful that is in terms of like the geopolitics of this situation. Just the U.S. is, I almost want to use the word glut of feedstocks.
Yeah.
The fact that we export a lot of these feedstocks when we could be using those domestically, I think is an underappreciated aspect of biomanufacturing.
Yeah, for sure. And it's one of our recommendations is around unlocking more flexible feedstocks is what it's called. So using more of those diverse sources of carbon and sugar across the US to be the input for biomanufacturing. And so we have a series of recommendations on how to do that. You could really think of taking things that are grown in your backyard and using those as the starting point to make the things that you need, truly circular economies at scale. Really exciting potential.
Yeah. Or going almost arguably feedstock free, pulling from like gaseous fermentation sources as first input. Let's talk more about this global geopolitical context. So of course, big tensions about adversarial competition are underlying a lot of this. But there's also a lot of opportunities for closer collaboration with our allies and partners. Could you just kind of add some color to sort of both sides of that dynamic?
Yeah. So I mentioned before, the state of play vis-a-vis the United States and China, and really, as I mentioned, China has made biotechnology a strategic priority for 20 years. And what we found in our report was that the U.S. has yet failed to do the same. And recognizing that biotech can play a role not just for health, but also agriculture and energy. And we've just spent a bunch of time talking about defense applications, right? The implications of that are large. This is really the next sort of battlefield of geopolitical competition, if you will. And without action, China is poised to win. They have doubled down on biotechnology across a number of aims and have used licit and illicit means to get a leading edge. This is a combination of non-market actions, and direct investments, heavy subsidies, things that advantage Chinese companies over US and create an unequal playing field in the biotech ecosystem. And again, as we said, this is now paying dividends, right? That we're seeing China not just fast follow the US, but out innovate the US. I mentioned some of the stats coming out around pharmaceuticals, where we're seeing an uptick in FDA approval of Chinese drugs, of these innovative licensing deals, movement of clinical trials going to China. Really, the entire ecosystem is kind of pivoting at the moment. But it's not just medicine. We're seeing signs in agriculture as well. China is now outspending the US and the EU when it comes to agriculture R&D. They've applied for more patents in one case when it comes to agriculture and CRISPR, which is this kind of bioengineering technique. So it shows the intersection of next-gen biology with agriculture. And just at the basic synthetic biology, which is kind of this engineering discipline underlying biotechnology, they are outpublishing us. And so where the United States used to have the most cited publications in synthetic biology in 2010, that is now completely flipped. Chinese publications are far and away outsited over US publications. Wow. So it's really just a complete restructuring of the global ecosystem when it comes to biotechnology. Again, this will have massive ramifications if we do not get this back and maintain the leading edge here. We lay out a number of ways that we need to act in order to do this in our report. It includes mobilizing the private sector. It includes fighting back against China's non-market actions, growing the workforce of tomorrow, continuing to out-innovate. And all of this must be done with our partners and allies. So pivoting to the rest of the world where we have our friends, the commission, as part of our work, not only did we talk to thousands of people here in the US in the biotech ecosystem, but we also talked to industry, academics, and government internationally and took trips as commissioners to visit parts of the world and learn about their biotech ecosystems. And we saw massive strengths across Europe, across Asia, Africa, South America. I mean, there's really a lot happening. So we must do all of the things that we lay out, all of those actions, we must do those with our partners and with our allies. It's not just partnering for partnering's sake, it's because there are great strengths across the world in biotech, and there's too much to do for any one of us. So those that share our values, that want the same outcomes from biology, want to gain from it collectively, we can work together in doing so, beat back some of the advantages that we're seeing come from part of the world that don't share our values.
Great. That's the zoomed out picture geographically.
Yeah.
I know you've also been doing quite the roadshow across the US and leaning into different regions and getting a sense of their unique strengths and capabilities. What have you been learning from that roadshow?
Yeah, this has been one of my favorite things that we've started doing since launching the report. So we started this Biotech Across America road tour. We've been visiting states and communities across the United States. We've been to 5 states, I believe, and more are coming. I'm going to one next week, to Oklahoma just next week, and we will have more coming in the next few months, really trying to hit every corner of the United States. And in doing so, we're seeing everything from biomanufacturing facilities for industrial products to the laboratory floors where they're making the next sort of innovative new drug, to talking to the people working in biotech every day, to those that stand to benefit from these products and applications. So I think what I've started seeing as bringing our recommendations local is just how much there is for biotech across the country, how much there already is, but how much stands to grow in terms of jobs, in terms of economic potential, and really how exciting it is to be in this ecosystem across the country. There's just so much potential here. There's so much positive energy. And we are trying to, as part of this tour, we're trying to lift up and show the community. So we have a real emphasis on local media and making sure to tell those stories to more than just a national audience.
One of the also, I think, underappreciated aspects of these kind of regional bioeconomy hubs is I think a lot of people think of biotech as happening in, university research labs on the coast, when really like manufacturing and full-scale production will happen near feedstocks, which is a lot of the middle of the country in the breadbasket.
That's right. These are jobs that can be anywhere. Right? People work in biotech across the entire country. So it's not like other tech sectors, which I think are concentrated in specific parts of the country or even in big, massive facilities. Biotech can be there's different scales, right, as you were describing. So it really is a very diverse and spread across the entire country, which is what's been so exciting. Everywhere from the Northeast to the South to the Midwest to the West. And again, those states will continue to grow as we rack up, all of our miles going across the country and visiting folks across the United States working in biotech.
Great. Let's turn to the meat of the Commission's report, which are these recommendations. As you mentioned, we're starting to see quite a few of these make their way into draft language in both the House and Senate versions of the NDAA, as well as other pieces of legislation. I know you've been spending an immense amount of time with policymakers, engaging them throughout this process. Yeah. What's kind of your sense of the current appetite and political will to embrace these recommendations?
Thanks for the question, Liz. I think you really hit on why some of the strengths of the Commission. One, we engage early and often. We are a legislative advisory board, right, as I set up at the very beginning. So Congress has been our constituency all along. To date, we've engaged with, looking at my notes to make sure I get the numbers right, because it is impressive, more than 430 meetings with over 300 member offices. And this is across both the House and the Senate. So it really just shows the breadth of who we have engaged with at the staff level, at the member level, at the committee level. Of course, we also have members of Congress serving on our commission. So they've kind of been our North Star along the way, right? Mm-hmm. We have 2 Democrats, 2 Republicans, 2 senators, 2 members of the House of Representatives. And so across the entire process, we were defining problems that were bipartisan, nonpartisan, and then solutions that could work for both sides of the aisle. And I think we really take care to build this platform that's seen as shovel ready when it comes to our recommendations. And I think that's what you're seeing with the uptake in the recommendations that we've drafted thus far, is the breadth of those that have been introduced already is really a testament to that kind of shovel ready nature of those legislations. So we already have 16 provisions and 3 funding frameworks in the NDAA. We've had 6 provisions in this year's IAA, Intelligence Authorization Act. And then it's more than just Congress. We're also seeing uptake at the White House as well and across the administration. So the White House recently released an AI action plan, and 4 of our recommendations around the intersection of AI and biotechnology made their way into that executive order. So that's really exciting to see. And more legislation is coming because Senator Young and some of his colleagues, along with Senator Padilla on our commission and Senator Kim, have previewed that they have introduced or are going to introduce a series more bills related to that AI and bio intersection. So we are at about half of our recommendations already being introduced in some form, and that number, is growing. But of course, we need to get them more than just introduced. We need to get them passed through Congress. And so we still have about 16 months left on our clock as a commission, and we are working tirelessly to work with Congress and help as much as we can to continue to move those pieces of legislation forward.
That's great. I'd love to dig into a few of the DoD specific recommendations. I'm especially kind of keen on a couple of these that are around market shaping, which I think is one of the most valuable kind of levers or functions that government can play to catalyze U.S. leadership in emerging technologies. The first one I'd love to talk about is 3.2a. Congress must direct the Department of Defense to work with private companies to build commercial facilities across the country to biomanufacture products that are critical for DoD needs. What might that actually look like? Is there precedent for engagement like this between DoD and the private sector for manufacturing capabilities?
Yeah. There is a lot of precedent for this. Is something the DoD does well and does often, is working with the defense industrial base to build manufacturing capacity for certain products. Why it's so important is that a number of U.S. companies are leaving the U.S. to do their scale up for bioindustrial manufacturing. As is not a surprise to this audience, as it is in other technologies, it is cheaper and more efficient in many ways to do this manufacturing outside of the United States. But we just talked about why there might be strategic reasons to want to have these supply chains here, right? Part of the advantage of biomanufacturing is that you can rebuild global supply chains where there is vulnerability by making them domestically. And so, there is a strategic reason to want to have that entire supply chain here in the United States. If we're starting with corn made in Iowa and coming out with a chemical for the DoD, we want that manufacturing facility to also be in the United States, or else it kind of negates the point of the supply chain resiliency of it. So the Department of Defense incentivizing the private sector to build these facilities here in the US and entering into those partnerships helps to create, the entire domestic nature of that manufacturing chain. And there are a number of precedents here broadly in manufacturing, but also in biomanufacturing. A series of public-private partnerships that already exist between the department and the private sector around biomanufacturing, things like BioMade, which is a manufacturing innovation institute that has a number of member companies that are innovating around biomanufacturing across the country. There's also a program called DMIP. In the DoD, we love our acronyms. The Distributed Bioindustrial Manufacturing Program, that is the beginning stages of something like this effort of incentivizing and helping companies build manufacturing facilities here in the U.S. that would have a Defense Department customer. Critically, these companies also need to have commercial outputs of these types of manufacturing processes. But the good thing about biomanufacturing is that it can be flexible, and there are categories of products that the DoD could use that, in a different flavor, if you will, could be sold to the commercial market. So a material for the department could be sold as a material for the automotive sector or something like that. And so there's a number of ways in which you could have both the interplay between the commercial and the Defense Department.
Great. Yeah, I also think a compelling thing about this sector is sort of fungibility between manufacturing facilities as well in terms of types of products. Just to draw a through line for our listeners for this series, through the Distributed Bioindustrial Manufacturing Program, a handful of those awards were made to companies that are doing food biomanufacturing. So just to kind of demonstrate that's kind of within this portfolio of defense needs, but also looking at that as kind of an avenue for scale up of biomanufacturing in general that could have some fungibility to other use cases. I'd like to talk about another recommendation, again, kind of in the market shaping private sector catalyst role here. This is recommendation 3.2D that says Congress should require the DoD to enter into advanced market commitments and offtake agreements for biotechnology products that are needed for defense. These are some really interesting tools. So similar question as before, what would something like this actually look like? Where have we done this before?
Yeah. So an advanced market commitment is the department saying to companies, if you make a product in the future that has these specifications, we will buy it at a certain price. Offtake agreement is saying if you already are manufacturing a product, we will buy it. This is really helpful for biotechnology and something we've already done. AMCs were used critically in Operation Warp Speed by the Department of Defense for vaccines, which went on to save lives. And so this was a real value add and was able to provide certainty to developers that if they made this product, that there would be a return on the other end. This is something that's really needed for biomanufacturing because in many cases, the bio-based product is competing with an incumbent that is abundant and at a low price point. And so as we talked about earlier, there may be a strategic reason why you'd want to have a bio-based manufacturing process, have that here in the United States, even if it's at an equivalent price point. But the market alone is not going to bear that out, right? There's no incentive for a company to continue to develop that if it's at price parity with an existing product. So the department saying that they will make this advanced market commitment for a product like that gives certainty to those companies to spend the money and the time developing said product, knowing that there will be a market on the other end. This is also a great signal to their investors, to the venture community, to private equity, to again, give some certainty around a market and enable the private sector to really come to play for all of the potential applications of biotech. We've done it before, we can do it again. And it really, we think, will be key in getting more of these bio-based products into the hands of the warfighter.
Yeah. It's really, I think, a great example of government kind of taking that risk to get technologies down the cost curve to a point that private sector can then step up and do their thing.
And that's exactly what we looked at across the report was what are the targeted actions that only government can take to really bring the private sector to bear across all of the applications of biotechnology. And these are things like these advanced market commitments. It's also things like regulatory streamlining that, again, helps to change that cost equation and just give more certainty to developers that there's a pathway to get their products to market, which is what they're looking for ultimately when they innovate in biotechnology.
Yeah, great. What additional closing thoughts or messages do you have, particularly to the defense industrial base, that you think they should be hearing, thinking about in this moment?
It's just to say that biotech is going to provide answers and solutions to many defense problems. So it's not going to solve every problem that exists for the Department of Defense, but it can solve many of them. And so I just encourage the community to think about biology, to reach for biology when they have problems and look to the biotech community as a potential source of innovation to help solve national security issues.
Fantastic. Thank you so much for speaking with us, Michelle.
Thank you, Liz. This has been great.
We've been speaking with Dr. Michelle Rozo, Vice Chair of the National Security Commission on Emerging Biotechnology. Thank you.